up here. There we go. All right, so first problem on Prequest number 2. Oh, these are the calculator problems. Okay, so what do I need to see on the paper? You're going to be using your calculator. So for number 1, it says solve using Gauss-Jordan. So the work that you have to show is the matrix that you're going to put into the calculator. Remember, the calculator is going to do all the work, right? Oh, I think that's a 1. Sorry about this copy. It really is not very good. All right? And then we're going to do what? Once we get that into our calculator, what are we going to do? RREF it. So somehow you have to indicate to me this is the button that I pressed. And then a new matrix is going to come out. So would you do that for me? Would you type that in? And let's see that new matrix that comes out. Hopefully it will come out normally and not be one of those weird things.
If it does, how do you do that fraction thing again? Smith, right?
Yeah. Okay, did you get them? Anybody have it yet?
We're getting there.
Getting there?
Yeah, that's weird.
Well, decimals are okay. I just don't want a whole bottom row of zeros.
Oh, yeah.
So what did I get on the top row?
1, 0, 2/3, 0.
0, 1.
0, 1, negative 5/3, 0. 0, 0, 0, 1.
Is that what came out? Did anybody else match that?
Yeah.
Okay, we have to talk about this then. That is a very strange thing to have happened.
I
had all
zeros
decimals
in the bottom.
I got it different, but yeah.
I
got it. Mine's all the same as the end.
Okay, let's try again. Let's put these numbers in again. Make sure you put the right numbers in. This is not what should happen. So we got a mistake somewhere. This is not what should happen. But if this does happen, it doesn't. This is the wrong answer. Somebody made a mistake here. But if this does happen, this tells me there's no solution. Because what does this bottom row say?
0 equals 1.
0z equals 1. And is that possible? Can 0 times something equal 1?
No way.
So this would be no solution, but that's the wrong matrix anyway.
Whoa.
Okay, can somebody give me the right matrix? 1, 0, what is it?
2/3.
2/3?
8/3.
8/3.
0, 1, negative 5/3.
Negative 5/3?
13/3.
13/3. And then zeros all across the bottom?
Yeah.
Okay, this happened yesterday too. I'm starting to be a little suspicious since it happened on both practice tests.
Do you think it might show up on the test?
Might show up on the test, a situation like this.
Like, what's the
So,
probability?
what does the bottom row say?
0z.
0z equals 0, which means z can be anything. So that's your first answer. Z can be anything. Now, tell me about y. Y minus 5/3 z equals 13/3. So y equals 13/3 plus 5/3 z. And then x plus 2/3 z equals 8/3. So x equals 8/3 minus 2/3 z. Now what kind of answer is that? Well, that answer represents infinitely many points, right? Because if you pick z equals 3, could you find a y and a z that go with that? Yep, but if you pick z equals negative 5, you would find a different y and z that goes with that. So you have infinitely many points that are represented by these equations. Tom?
Do we have to plug numbers in and get
No,
answers?
this is the answer.
Awesome.
Okay. Next. Okay, so what I want to be clear about is, it isn't just the answer that I'm looking for. You have to demonstrate that you know the method you're supposed to be using. So I need to see this matrix, I need to see that somehow, and I need to see this matrix. And then I need to see the answer. For the next one, we're solved using the inverse method. Okay? Ultimately, what are we going to do to get the answer? We're going to press A inverse times B. In order to accomplish that, we're going to have to put in a matrix A. Right? And what is that matrix going to be?
Coefficient.
It's going to be the coefficients. So 1, 1, 1, 1, 2, negative 1, 1, 0, 1, negative 2, 1, negative 1, and 1, 1, negative 2, negative 3. With the inverse method, we put in two matrices. We put in an A and we put in a B. What's our B? 10, 7, negative 1, and 0. Tom?
Are we going to have to do the inverse by hand?
You're going to have to do the inverse of a 2 by 2 by hand. That would be question number 6.
Okay.
So we got this matrix in and we got this matrix in, right? And then we write this down on our paper because these are the buttons we're pressing. And then we should get an answer. An answer should come out of that. When you do A inverse times B, you should get a set of numbers. While I'm thinking of it, people, remember, when you take your exam, I will not be there. You have got to show up with your own calculator. If you do not have a calculator, you will not be able to do half the exam, and no one there will have a calculator for you. Okay? Spooner or Mr. Wynn or whoever is proctoring will not have a supply of graphing calculators. You must remember to take your own calculator to the exam. All right, did anybody get an answer here?
4, 3, 2, 1.
4, 3, 2, 1. How nice. So we write down on the other side, we write down the answer 4, 3, 2, 1 as a nice little ordered pair, ordered quadruplet. Now, number 3 is actually the same kind of problem, but we're not doing it with the calculator, and we're doing it using a different method yet. We're doing Cramer's rule. So again, it isn't the answer. The answer is important, but you don't get credit for the answer if you haven't done it the right way. So for Cramer's rule, what kind of work am I going to need to see? I'm going to have to see a determinant. And the first, I'm actually going to have to see 3 determinants. But the first determinant I'm going to see is 2, negative 3, 1, 5. Would everybody agree with that? That's the determinant of the coefficients. And that determinant equals 13. If you don't know where 13 came from, you lean over and ask your neighbor. We got to get that set right now. The determinant here is 13. Now what's the next thing I should see on your paper? X equals, that's, you're trying to find X and Y, and you're going to have both of them over 13. And you'll have little determinants here on top of those 13s. Do you remember how to find those numerator determinants here?
8, negative 7,
We're going
negative
to
3,
take the
5.
8, negative 7, and first we're going to put it here, and second we're going to put it here, right? And the other piece stays the same. And then we evaluate those. So let's see, that would be 40 minus 21. What is that? 19? And negative 22. double check my arithmetic. And then we'll write our answer as an ordered pair, 19/13, comma, negative 22/13. Everybody okay with that? Number 4, okay, now we're switching gears. Number 4 is find the area. You did this one last night in your homework. I think that's 1, negative 1, I can't read it. What's our strategy? Remember, this is a no calculator problem, so that limits us. We can't really do 1/2 side sign without a calculator. So, who remembers what work do I want to see on this one? I want to see 2 vectors. And because I'm a creature of habit, I'm going to use CH and CS. You do not have to use any particular vectors. You just need to name 2 of them. I'm going to use CH and CS. So what are the coordinates of CH? CH. 1, 3. And CS?
3, 2.
3, 2. Are we okay with that, folks? What do I do with those 2 vectors now? I just make a determinant out of them, so I'm just going to slide them over and put them in a determinant here. And we observed yesterday, at least in one of the periods, I can't remember, it doesn't matter how you arrange those vectors, the order of them doesn't matter, just get them in there. What's the value of that determinant? Negative 7. So what's the area of the triangle?
7.
7/2, 3.5, 7/2. Remember, you make it positive and divide by 2. Take half of it. And that would be the area of the triangle. Number 5. No directions as to how to solve, so you just got to kind of look at it and figure out what might work best for you. Doesn't tell you how to solve it. It's a system. What do you think? What's your thought when you look at that?
Subtract x, divide by 2.
Times the top by 2. I love that, Katie. Times the top by 2. And that would give me this, right? Now she did that. Everybody see why? She's going to add them. But be careful. When she adds, these don't add together. That's x squared plus 2x equals 3. What kind of equation is that? So we got to get it set equal to 0. And then you decide how you want to solve it. It does factor, but of course you can always use the quadratic formula. Most of you don't have trouble factoring when there's no number out here, so you probably factor that. And we get 2 x values. Negative 3 and 1 in the plate. Yep, you're done. So are you all caught up now, Jabron?
I believe so.
Does that mean I'm actually going to go 24 hours and not get a text from you?
No, that doesn't.
That does not mean that?
You're one of my texting buddies.
Oh, okay.
You might go to.
All right. See you in a few minutes,
Yeah,
Jabron.
Snapchat, you can be my best friend.
I don't even know what that is.
I'll make
Okay.
one for you.
Negative 3, 1, those are my x values. Now, you need to go back. If x is negative 3, you need to figure out what the y value is. Okay, so negative 3 minus y equals 3, so negative y equals 6. I got negative 6, did you? 1 minus y equals 3, negative y equals 2. I got negative 2, but double check, I could have made a mistake with my arithmetic. All right, any question about that? Number 6, solve using the inverse method. Now, we already did one of those up at the top on our calculator. This one we're doing by hand, but the principle is the same. You are going to be multiplying A inverse times B. That's how you get your answer. So what do we need to find? A inverse and B. Now, B is easy. What's B?
3.
B is 5, negative 5. Now, what's A? Not A inverse yet, but what's just matrix A? 1, 1, 2, negative 3. How do we get from matrix A to A inverse, which is what we need?
Find the determinant.
First, we're going to switch. Well, I say first, it doesn't matter what order you do this in. These two have to switch places, and these two change signs, right? But that's not it.
Determinant.
You have to multiply it by 1 over the determinant. And what's our determinant?
Negative 5.
Negative 5. So we are going to multiply by 3/5, 1/5, 2/5, negative 1/5. There's A inverse. 1 over negative 5 times that new matrix that you built. And this is going to give me my answer. This works out nice because they're all over 5 and I'm timesing by 5. So that's 3 minus 1. I got 2. And 2 plus 1, I got 3.
Row, column.
Row 1 times column 1. So my answer is 2, comma 3. Now I'm going to skip 7 because I'm going to have you work on that with your partner. Let's do 8 and 9. 8, find the partial fraction decomposition. What's our strategy here? First we have to factor, don't we? Okay? Now what? Yeah, you need to say this is going to equal now 2 little fractions added together. And the denominators of those fractions are x minus 4 and x plus 1. And the numerators are unknown. That's what we have to figure out. We don't know what the numerators are. Now we'll multiply by the bottom. And the reason that we're doing this is so that we don't have these fractions anymore. So here we go. That's all gone. So we have 6x minus 34. Here we have ax plus a. Perry, are you doing what I'm doing?
No.
God bless it. Bx minus 4b. All right? Now, this is the point where we've got to break it apart now and get our 2 equations. So, what are our 2 equations going to be? Look at the x parts first. What does that say to me? 6 equals a plus b? What does the other equation say? Negative 34 equals a minus 4b. Now you're going to solve that however you want. For me, I kind of like the idea of just multiplying the top one by negative 1. But you don't have to do that. You can solve it any way you want. So I have negative 40 equals negative 5b. I got b equals 8. if B equals 8, then what would A have to be?
-2.
-2. This is not good enough. You have to tell me what the partial fractions are. So 6x minus 34 breaks down into -2 over x minus 4 plus 8 over x plus 1. That's the answer. Those are the partial fractions. Any question about that? Then the last one is a quick little sketch, and this is an easy one because we don't have to do any factoring. Sometimes we have to start by factoring, remember? And then sometimes things cancel out, remember? Which give us holes. Well, we're not factoring or canceling in this problem, so there are no holes. We're ready just to sketch it. What do I have to put in my picture? What will I be looking for? It says in the directions, show all intercepts and asymptotes. So, do we have a vertical asymptote? Yes. X equals 3. One more time. Last time I'm probably ever going to say it to you. Vertical asymptotes happen at what cannot be. X cannot be 3. So that's going to be a vertical asymptote. It makes your denominator 0. Do we have a horizontal asymptote? It's y equals 2. Because the limit of this thing, if you look right here, when the powers match, we compare them. So 2x over x. That's 2. Do we have a y-intercept?
Yeah.
Of course we do. If you put 0 in, you get
1/3.
-1/3. Do we have an x-intercept?
Yeah.
Of course we do. If you set this equal to 0, it says 2x plus 1 equals 0, which means x equals -1/2. Is there enough in that picture for you to sketch it? Probably. It's a pretty basic picture. What might happen is some of you will do that and call it quits. Remember, you have to graph on both sides of the asymptote, the vertical asymptote. So what's happening over here on the right side?
Same
This,
thing.
right? But if you're not sure about that, you can plot some points. Now, what I want to do now is I want you all to be working on part 7 with each other, checking answers, cross out 10 again, we didn't do 10. Checking answers either with my work or your neighbor. And while you're doing that, I want to turn back all these papers that I still have. So, John, you want to hit that video there? And I'm going to turn back